Hi class. This is another example of hypothesis test for proportions. So example, suppose you heard that 30% of people actually quit drinking soda because they're trying to eat healthier. You sampled 200 people and 72 said that they no longer drink this stuff. Can we infer that more than 30% no longer drink this terrible liquid soda? Okay. So we'll use the default significance level, alpha 0.05, which is the same as a 95% confidence level. Alpha is the probability of making a type 1 error, which is wrongly rejecting a true null hypothesis. So we need to set up the hypotheses, and let's see. So we normally set up the alternative to figure out what we can possibly infer. Because the alternative is what we could possibly infer, and HO is a null hypothesis, which is the default assumption. So what are we trying to infer? Can we infer that more than 30%? So P would be greater than 30%. And the null hypothesis is the opposite of that, so less than or equal to 30%. But I want to emphasize that you can just say equal, and the key thing is the equal, because we're gonna use the equal sign to set our assumption, and so that we can calculate a p-value. Okay. So alpha is 0.05. We have to see if the sample results could possibly allow us to infer HA, and our sample result is 72 out of 200, which is 36%. 36 is greater than 30, so we could possibly infer the alternative. Now, how come we don't automatically infer the alternative? It is greater than 30%, and that's an important question. The answer, the very important answer is we don't automatically infer this because sample results vary. Another sample, we might get a different thing. So we have to figure out how unlikely it is to get this sample result, or more extreme, the p-value, under the assumption of the null. And if it's really unlikely to get this sample result under the assumption null, then the assumption null is probably false. That's the logic of a hypothesis test. Okay, so we need to calculate a p-value, and the p-value is the probability of obtaining the sample result or more extreme, assuming the null hypothesis is true. All right, so our sample result was 72 out of 200, or 36%. So what's the probability of getting 72, that sample result, or more? Well, that would be the probability of 72 plus the probability of 73 all the way up to 200. And really, this is a binomial situation. Either you quit drinking soda or you didn't. So it's binomial. So the exact probability would be adding up all these. And so that would be the same as 1 minus the probability of 0, probability of 1, all the way up to 71. So we can say 1 minus binom cumulative, and it's NPR. It's 200 NPR. N was 200. P is equal to 0.3, and up to 71 NPR. National Public Radio, to remember the inputs to that. And on a calculator, we get exactly 0.004. And we can see that on a calculator. We can just kind of bring that in. We turn on. Okay, and we go to second distributions, and we have it all right here. And the binom probability cumulative is in second distributions. So, okay, so it's 0.04. All right, which is less than our willingness to make a type 1 error, wrongly rejecting a true null hypothesis. It's less than our alpha. So it is unlikely enough. It's getting this sample result is pretty darn unlikely. It's less than our willingness to make an error, so we're going to go ahead and commit to this, that it's greater than 30%, although it might be an error because it's sample results, and sample results vary. Okay, so since the p-value is less than alpha, do reject HO. There is sufficient statistical evidence to infer that more than 30% no longer drink soda. Hallelujah. Definitely don't drink soda. Okay, hope that's helpful, and you enjoyed it.